we have an enterprise story. And it's often quite strange when you have downloaded an app and then you meet the person that's devised it, and then you suddenly realize when talking to them that the app has had 200 million installations across the world. And that's very much the case of our next enterprise story. Algorithmic trust and medical soundness in femtech AI. We're talking about a flow journey. And to tell us more, we'll be hearing from Andrei Varanovich, the head of data science at Flow Health. It is, it's a fascinating app, one that I've used and many women around the world continue to use, made by man, interestingly. Andrei, welcome.
Hello.
A round of applause, please.
Thank you. Hello, everybody. Hope you're enjoying the venue, and thanks for attending my talk. So my name is Andrei, and I want to actually talk about our journey so far in a quite fascinating area. So it's kind of the area that combines, the impact, the medicine, the AI, ML, all of those things. And I actually, as a part of my talk, I want to it's not going to be like conclusion, but it's going to be like a direction which I invite, I think, all of you to kind of think together about those challenges that we faced so far and the potential direction that, we are thinking is the right one. So a little bit about Flow. Flow is actually #1 app in the health and fitness app in iOS marketplace. We have a pretty large install base, and actually I think most of the women know what Flow is, but actually it's our, we say, like go-to app when it comes to the women health, and we're doing a lot of stuff around like reproductive health, things like that. We are almost a unicorn as of September 2021. And we are actually growing as a business, but also in terms of impact that we make. In essence, so I want to kind of simplify a little bit for the sake of a focus on the story. So what do we do? And this is something that we call like a core experience. So one part of our core experience is actually we have an app where women can sort of track what we call symptoms. So it's starting from, from the mood, all kind of, symptoms in the body, all sort of events that are happening in their lives. And then what we do is with machine learning, we predict in what stage of your cycle do you find yourself, and when, let's say, the next stage of the cycle will start. So it's kind of, we try to predict basically a cycle length for the women, right? So that's kind of our core machine learning use case, which I want to talk about today. And so the challenge that we face is this, right? So we have all of this, kind of 40+ million users and women around the world, and obviously, like, every woman is unique, right? So we call it like everybody is different and everybody is different, right? So there is no like kind of universal solution for this sort of cycle prediction problem. And so the consequences of this is the following, right? So if I like simplify, how machine learning works. We take some data set as an input, we train this something that we call machine learning model, right? And then this machine learning model is kind of based on our historical data set, is trained, and so based on the new data, so new symptoms, let's say, it's going to kind of predict a new value, right? This is a very classic example how people understand what machine learning is, right? And so putting this in our context, basically how it kind of worked, right? If we translate that concept into Flow, we have 200 million users, so 1+ billion actually data points in the data set. We have all of this history, cycle history. We have this black box model, right? And that black box model actually, like, the new user enters the data, and then it predicts your period is starting in 70 days, right? So this is more or less like a workflow, how it works, or how it used to work. There is one big challenge. This approach, so this model is very biased. And actually, the bias is coming from the individual goal of the app usage. So thing is that, as I said, every woman is different, and every woman has a different goal. And as our app supports multiple goals, actually, I wanted to give you some scenarios where, depending on your goal, the model gets biased a certain way, and this is like reality we have to deal with. So let's say one scenario is the woman wants to get pregnant, and this is the mode which we call trying to conceive, right? So that means that obviously she logs what is important to her, right? She logs like sex activity, ovulation test results, and she logs it very consistently, right? Because that's something that actually the most important in that sense for you when you want to get pregnant. And so at the end of that, our model is likely to have this cycle that actually pregnancy, right? Because when you get pregnant, then your cycle stop, and you don't report that, so we get cycle that never ends, so very long one. Also, this person has a perfectly stable BMI. Why is that? Because you don't track your wife or something, right, during that. If you want to get pregnant, it's not something that you think about. So you entered your wife on the onboarding, and it feels like you have a stable BMI, right? But also, of course, it also appears more sexually active among of the users. Why? Because you logged what is important for you, right? So the second scenario is we have a woman who is more concerned about, let's say, emotional aspect of her life, right? Anxiety, mood, other mood-related symptoms, right? But also, what she wants is she wants to track her weight. And so as a result of that, that woman has a very different goal, right? Very different scenario and very different usage pattern and the expectation from our app. So what that means for machine learning is that she's going to look like sexually inactive because she doesn't track it. But that might not be true, right? On the other side, she might look like someone who has like a hard time, right, in her life because she consistently tracks, mood-related symptoms. And the BMI is going to be unstable. Why? Because, well, it's changing, right? So depending on this scenario, we have like completely different sort of bias, which is, we have to deal with. And so then the third scenario is we have a new user. So someone starts using the app. And remember, we have a machine learning model that learned on those previous patterns, right? And then all of a sudden, well, the new user decided to start logging sex. And what happens is that, guess what? Because her prediction gets jumps from 28 to 32 days. Why is that? Because, well, the model is very biased toward that sort of activity because it mainly logged by the people who have different goals, right? And then she calls support and says, well, but that's nonsense, right? And she will be right, because it is nonsense. Why? Because, well, that's how black box machine learning model works, right? So we took this data set, it inherently learns those patterns, and then, that's what we would end. So we think there are three challenges, basically. It learns suspicious patterns. It captures bias, obviously, right? Like as I showed. So those are like very real examples. And the most important for us is that that approach, it has little or zero actually medical knowledge, right? So what I talked about, cycle length prediction, it happened to be like a health-related use case, but actually there is nothing health-related in this process, right? You take the history as a data set, you take all of this data point, train the model, and so be it. But there is no medical information or medical knowledge embedded in this process, right? And this is a big challenge. Why? Because, well, we have to be like responsible, right? So we cannot use solid black box model, engineering model to predict something that appears like it impacts the health and well-being of the women. So how was it solved? Well, it was solved up until some time by actually doing some sort of manual segmentation. So we understood those big patterns and those big scenarios and the goals of the people, right? And we had predefined segments. And like, this is a trying to conceive user, this is that, that is this. And they've been served by different black box models. But also, we had some post-processing in place to make sure that we don't have this crazy, like what we call jump, right? From 28 to like 35 all of a sudden, because normally that's not how women's cycle really works. So that was an approach so far. But that approach, well, it's not scalable, right? It is still like very sort of manual in a way. We have to know the segments, right? We have to have quite a lot of all kinds of analytics, all kinds of work to be done before, and still there is no medical knowledge in there. So, and we started thinking about this term, which we call medical soundness. So medical soundness for us is like a way to incorporate the medical knowledge, the medical fact, something that is known from medical science into our machine learning models, okay? And we have actually a medical team in the company. Those are the experts in medicine, basically, right? And so there is all this history of medical science, papers, all of that stuff. And so the challenge is, like, to be medically sound for us is basically means that to make that medical knowledge work in our machine learning work. So that's kind of the challenge, how we framed it. And so the first step that we did is the following. Well, like the first, I think, thing that comes to mind when it comes to all kinds of, like health-like machine learning, it has to be explainable, right? And what about explainable is that, as I said, if model learns nonsense, we explain nonsense, right? So in our case, explaining things, this is already too late because, it learned those suspicious patterns that we don't understand, and so explaining them would not help users, right? So explaining nonsense to the users is not satisfying because say, well, but that's nonsense, right? So I think it was quite, let's say, counterintuitive, right? But if you really think about this, is that depending on this sort of bias and how your data is collected, like explaining, the feature importance or how machine learning works, it is already too late because you are just explaining those suspicious patterns that machine learning kind of inherited from those data sets, right? So we've kind of, again, it sounds a bit of a bold statement, but for us it is very clear that we had to look into like other means, right, and other mechanism. And so the first effort that we started like looking at, as I call, we had to make symptoms work. Right? Because remember, like the symptoms, we have, I think, around 40 symptoms in the app, which represent all kinds of, emotional, physical, other activities. That's what we call symptoms, right? And so obviously, like the medical experts tell us that, certain things like headache or, tender breath or the others, they do affect your cycle. So that is what is known by medicine, but so far it was not incorporated in our machine learning, okay? So what we did is we did actually an effort where we collected, we call it a golden data set. So it's not really a clinical study, but it's kind of, we took a control group. So we took X amount of women, and they have been reporting very disciplined, all kind of symptoms over some period of time, half a year, that they've been experienced. So we had the data set. I mean, again, I call it clinical, but it's not really, we are not a hospital and not a clinical study, but it's kind of clinical-like study where we have this golden data set. We know that the data, it's objective, we could trust. And so then what we did is that we talked to our medical team and tried to understand which group of symptoms, in what order, in what combination, do affect the cycle. Okay, that was the kind of the second step which we undertook. And then we incorporated that knowledge into machine learning as a mean of shape constraints or monotonic constraints. I'll come to this a little bit on the next slide, how it actually really looks like. But actually, we made sure that the behavior of our model is predictable in the sense that it follows what the symptoms pattern kind of tell it to do, okay? And so we checked then these results against our golden data set, and then we integrated that black box model into our data set of our whole users. And so what is this actually, the shape constraint? So shape constraint is the way to kind of apply some actually constraint as to technically speaking, to make the shape of your function behave a certain way. And so what you look on the left side is that that is the impact of tender breath, which is a symptom on a prediction. And if you compare that picture from the right side, what you see is that you have this lower right corner and upper left corner, they're completely like clean. So that means that the tender breast symptom that you log, it impacts the model either positively or negatively. So this is where the positive side and the negative side comes. But it is predefined. So you do not see anywhere where the positive part of the symptom impacts the model on the negative side, which you see actually on the left side, right? So on the left side, you have positive impact on the prediction, but actually negative, so it's the symptom that you had beyond the actual cycle, right? So that's kind of the whole concept. As I said, it's a well-known concept. It's not that, let's say, sophisticated, but basically it's a concept which allows us to constrain the behavior of our model in a certain way so that it is predictable according to that input, which is in our case symptoms, right? So, and that was kind of quite, let's say, quite a breakthrough, right? So at this point of time, we can say that our models actually do behave, at least the change in the cycle prediction, it is according to the medical knowledge grouped by a number of symptoms that do impact the cycle, okay? And so, I mean, it's technically a simple mechanism, but it is pretty powerful in a way to sort of, move towards this embedding medical knowledge into machine learning. So that is like where we are kind of right now. So we find some way to, incorporate this knowledge into our machine learning models, and so kind of where we are going. And this is where there's going to be a least covered part, because we are also at the very early stage of like discovering this. But actually, the fundamental thinking is that we have to move away from what's so-called associative machine learning into structural machine learning. So we have to move from the kind of pure black box models, right? Because they learn suspicious patterns, and it's too late to explain them, into something that is called the structural machine learning sometimes. And so the whole idea behind the structural machine learning is basically we want to encode the medical knowledge, so the causalities that are known from the medical study in a sort of graph. And this approach is known very well in the health domain, in the classical health domain, for those people who kind of worked in expert system, sort of with expert system type of problem. And that what we want to do is that based on this graph, we want to generate basically a test, so a set of axioms, and our model has to then comply with those tests. So it has to pass those tests, right? And so this is kind of all our definition by incorporating medical knowledge into machine learning. It changes into something like the medically sound ML is the model that satisfies those tests that are coming from the graph where all of the medical constraints and medical priors are defined. And so there are several methods to constrain that behavior, right, based on this test. We are also kind of exploring this one. But I think my key message is that in the kind of health-like problems, we do believe that we need to kind of think at it a little bit out of the box, right? And perhaps discover completely new ways or different ways to think about what actually machine learning means. Because I think that for a traditional or classical machine learning, engineers, researchers, it has always been this kind of data set, black box model, and then we have a problem, right? With the users, with the regulators, with, I mean, a lot of problems, and how to solve it. So our understanding is that we need to go back to the kind of root cause of this problem and rethink how do we constrain our approaches to machine learning so that it has already this a priori some kind of constraint mechanism based on the tests that it's satisfied. Okay, and so where we believe is that the key promise with this approach is that medical soundness by design, right? So the model is built in a way that is medically sound. So all of this encoding of this knowledge allows us to collaborate with the medical team, right? So we kind of have they signed off on the medical part, and then that way the model behavior aligned with the medical priors, and that's actually the direction that we are thinking, or we're exploring right now as we speak, and I believe the broader community that is working in a kind of health-related domain should also potentially sort of, join this conversation, and at that point, that's kind of our vision looks like. We're moving from black box through interpretable ML into kind of constrained interpretable ML, right? And so that journey would kind of allow us to really go in a health-like scenarios with machine learning that works according to the medical kind of constraints. And so on that note, actually, that's it from my side. So thanks a lot. I should say we have actually a booth over there. So if you want to kind of continue this conversation, or you have some thoughts of this, you're welcome. I will be at the booth, so we can continue the conversation there. But at that point of time, thanks a lot. Thank you very much.